In the previous session, we have discussed regarding the multiple regression and the meaning of partial regression coefficients. Today, let us take up assumptions in the multiple regression. What are the assumptions? As usual, in the classical linear regression model, here also some similar assumptions are there. Let us see one by one shortly. So, linear regression model or linear regression parameters. Next is linear in the regression model and the linear in parameters. Linear in the sense there is no power of degree 1. So that is the meaning of linear. Linear means of degree 1 or power 1. Now if it is x squared instead of beta 1 plus beta 2 x squared, that is not linear, that is quadratic. So linear means of power x, that is the meaning. This is the parameters. So linear in regression model and linear in parameters. Next is fixed x values or x values are independent of the error term. Means the two independent variables in the multiple regression we are considering here two independent and one dependent. So total 3. So two independent variables is x2i and x3i. These are they are not correlated with the disturbance term. Disturbance term, where you find the disturbance term? There is no correlation. That means see, in the example of the crop yield estimation, we are considering, suppose rainfall is independent variable, crop yield is a dependent variable. Along with rainfall, we also consider the land inclination. So land fertility and land inclination is different. Plain land like Mudgod, Dharwad side, almost plain. In that is plain area, but in our area, means in Uttar Kannada, like this district, we find some slopey area, that is inclined. Fertile is different from there. So that is different. That included. So yeah, if we are considering only two factors, if at all there exists more than two factors, then we are considering it in the disturbance term or the error term. So this error term does not, they are independent of this term. Means the covariance between these two terms is 0. That is the meaning. Next is zero mean value disturbance. That is correlation between these two values. Zero mean value disturbance ui for each I. Next is homoscedasticity or constant variance. That is variance of ui. So variance of the disturbance term is constant. That is sigma squared for all I. Now autocorrelation. Autocorrelation means two regression, two disturbance terms is there is no correlation between. Means in the sense, instead of see, suppose error term is land inclination and fertile, say land fertility. These are the actually disturbance term, error term. What does it mean is, see, there is no autocorrelation in the sense as inclined increases, fertile also increases. So they are correlated. Such thing is, so no such things happens. That in this case, that is assumption is there. That is assumption. The number of observations must n must be greater than the number of the parameters. There must be variation in the values of x variables. No exact relationship between x2 and x3. In the sense, the two independent variables, they are not correlated. There is no exact relationship. So there is no specification bias. No either biomass is assumed. These are the assumptions. Next is then the testing of overall significance of the sample regression. So what does it mean? So far we have discussed the t-test, which was using for testing the two variables, between two variables. If it is more than two variables or two two independent variables are simultaneously influencing the dependent factor, then t-test cannot be applied. So in such cases, we use the significance of sample overall significance of the sample regression. That is the meaning. So far we have considered with the testing of hypothesis the estimated partial regression coefficients individually. In the sense, in the previous examples I have explained, we are considering the partial coefficients and compared with the other factor, keeping other constant. I have said like that. So we are not considering all the factors, all the partial regression coefficients simultaneously. So we are considering each wise. That is the meaning. So coefficient individually, that is under the separate hypothesis that each population partial regression coefficient was 0. But now consider hypothesis. Null hypothesis equal to beta 2 equal to beta 3 equal to 0. In the previous example, while applying the t-test, we are using beta 2 equal to 0 versus the alternative hypothesis beta 2 is greater than 0 or less than 0, or beta 2 is not equal to 0. It was like that. But in this case, we are considering beta 2 equal to beta 3 equal to 0. In the sense, both all the two factors are simultaneously influencing the dependent factor. That is the meaning of this. So thus null hypothesis, jointly influencing beta 2 and beta 3 are jointly or simultaneously equal to 0. A test hypothesis is called a test of overall significance of the observed estimated regression line. That is whether y is linearly related to both x2 and x3. So this type of questions may be asked in the MCQ, multiple choice question. So they give us one statement. The testing the overall significance of sample regression means. They give the 4 answers. They give jointly influencing, or similarly, if it is the right answer is jointly influencing on the dependent variable. Next, so how to test that? So the analysis of variance approach, testing overall significance of an observed multiple, F test. We are using F test. In such cases, we use the F test. Remember, t test is applied only between two variables. So whenever only one independent variable influencing the one dependent variable, then we use t test. You can, but if two independent factors are influencing the dependent variable simultaneously, two factors simultaneously, that type of test cannot be applied by the or for overall significance of, for those, in such situation t test cannot be applied. So in such cases we use or we apply F test. The actual procedure is like this. That is called ANOVA. ANOVA means analysis of variance. So TSS equal to summation yi squared, and this is explain sum of squares. It is beta 2 into sum of yi x2i plus beta 3 cap sum of yi x3i. These are the explained sum of squares, and the residual sum of square is sum of ui cap squared. So TSS has the usual n-1 degrees of freedom, and RSS has n-3 degrees of freedom, and this explained sum of squares has 2 degrees of freedom, since it is a function of beta 2 cap and beta 3 cap. Under the assumption that the normal distributions, and for the null hypothesis we use the statement of null hypothesis equal to beta 2 equal to beta 3 equal to 0. If there are k factors, say, then beta 1 beta 2 equal to beta 3 equal to beta 4 etc. up to beta k factors variables equal to 0. Here we are considering only two factors, two independent factors, one dependent factor, totally 3 factors. So that in such cases the F test can be applied like this. F equal to beta 2 cap into summation yi x2i plus beta 3 cap into summation yi x3i divided by 2 divided by this raw sum of squares divided by degrees of freedom, or raw sum of, not raw sum of squares, residual sum of squares. So this equal to exponent sum of squares divided by its degrees of freedom and residual sum of square divided by its degrees of freedom. So it is distributed as f distribution with 2 degrees of freedom. Now this analysis of variance table for the two variable regression. Two variable means one independent and one dependent. That is two variable. For in the such cases, the analysis of variance table will be like this. First column is source of variation due to the regression. That is exponent sum of squares. Sum of squares, and degrees of freedom mean sum of squares. Mean sum of squares is obtained by dividing it by its degrees of freedom. So dividing the sum of squares by its degrees of corresponding degrees of freedom is the mean sum of squares. Due to the residual, that is RSS, and total sum of square, that is yi squared, and sum of square due to the regression equal to sum of yi cap squared equal to beta 2 squared cap into summation xi squared. So mean sum of square is equal to beta 2 cap square multiplied by summation xi squared. Similarly, due to the residual, sum of square is equal to sum of ui cap square, and degrees of freedom is n minus 2, and this sum of ui cap square divided by degrees of freedom is n minus 2 equal to sigma cap square. This is the mean sum of squares and the total sum of squares. That hence f equal to, the formula is mean sum of squares of exponent sum of squares and mean sum of squares of residual sum of squares. So that is equal to beta 2 cap square into summation xi square divided by sigma cap square, where mean sum of square is obtained. This is for two variable regression, but we are considering here multiple regression, that is 3 degree. So this is 3 variables. So the analysis for the 3 variable is like this: 3 variable regression. So beta 2 and beta 3 and x2 and x3 are the two independent variables, and coefficients are beta 2 cap and beta 3 cap. So the source of variation, sum of squares, degrees of freedom, and mean sum of squares. And first row, due to the regression is the sum of squares of due to the regression is this beta 2 cap into summation yi x2i plus beta 3 cap into summation yi x3i, and degrees of freedom is 2, and this first column, sum of square divided by its degrees of freedom, is the mean sum of square. Similarly, residual, so dividing by residual gives you the f distribution. Due to the residuals, that is residual sum of squares is equal to sum of ui cap square, and its degrees of freedom is n minus 3, and the mean sum of square is, so sum of ui cap square divided by its degree of freedom, that is n minus 3, equal to the mean sum of square equal to sigma cap square. This is the f test. Regarding the f test, let us see the example in the next session. Thank you.